Just wanted to provide a quick overview of PERT using triple time estimates. Incidentally, this is the example that's right out of the book, uh, and you should be able to find it as far as finding the critical path, the different components, the activities. It's the one we talked about in class as well that has the optimistic, most likely, and pessimistic times. So to follow through with this, simply go to the matter of fact, you may want to pause, go back to the textbook, find the sample that runs the whole way through the PERT critical path chapter to follow this through. What I want to do though is to provide you an overview of how QM for Windows does an excellent job with triple time estimates. Then all I did was go to to module, PERT critical path, click on File, New, and then select 1, 2, 3, 4, 5, 6, 7, 8 different activities. And also click on the triple time estimate rather than the single time estimate. And then these values, for instance, activity 1, optimistically, they can do it in 1 week, pessimistically 3, but most likely it's 2 weeks. And of course, we discussed all this in class and have gone over it. In addition, the chapter does a wonderful job with it. But running it on QM for Windows just does a spectacular job. You see, I've set up the precedence diagram already, so that's ready to go. And given that I've loaded up the most likely, the most optimistic, and the most pessimistic time, as well as setting up the predecessors, all I have to do is click Solve. What this does is it finishes off the problem. Not only does it do the normal stuff, for instance, provide the early start, early finish, late start, late finish, it provides you the slack. Of course, all the ones in red are for the critical path. But most importantly for my discussion here, it provides you the standard deviation for the critical path. You don't have to go through and do the calculations for the variance. And we, of course, went through those in class. Just select the items for the critical path, in which they've done here, and provide you the standard deviations for each item of the critical path. It provides you the project critical path. If you do want to find out what the probability of completion is, again, as we discussed in class, use that equation of z is equal to x minus the mean divided by the standard deviation. Or if we want, our average is going to be 15, we expect most likely we're going to finish this up in 15 weeks. But if we want to know the probability that we complete it in 17 weeks, we can use the standard deviation, use the 15 as our weeks, and then be able to use actually our x, which is 17. We want to know the probability that we can do it in 17 weeks or less. We've got our standard deviation, as I'd mentioned twice already, right here. And now we can also do something else. We can go in, click on this little blue bell curve, click on that. Automatically, it will load the 15 for our mean. It'll automatically load up our standard deviation. See it right there, variance for that matter. What we want is we want the probability given values. We want a one tail. And we want to know the probability that we can complete this in 17 weeks. So our cutoff is going to be 17. We click compute, and we know that there's an 87% chance that we can get this done in 17 weeks or less, and of course a 12.84% chance that we can do it in 17 weeks or more. We could go back and look at what's the probability that we can do it in 16 weeks. Oop, that was a mistake because our mean is still 15. What is the probability that we can do it in 16 weeks? We put that in our cutoff. We compute, and there's a 71% 95.46% chance we can do it in 16 weeks or less, and a 28% chance that we can do it in 16 weeks or more. So what this does is it allows us a very quick and easy way to do these triple time estimates without having to go through all the hoopla. And in fact, of course, the real gift is simply by clicking on this bell curve here, it will self-load these. Click on one tail, probability given value, one tail, and what is the chance we can get this done in 18 weeks? Plug in an 18, and kaboom, 95.55% chance and only a 4.45% chance that for 18 or more. Again, a nice trick. I hope this is of value. Thank you very much.